Welcome to University Calculus. Today we're exploring the fundamental concept of limits. Limits help us understand how a function behaves as the input approaches a specific value. They are the foundation for derivatives and integrals. The limit of f of x as x approaches a is written as limit as x approaches r of f of x equals L. This means that as x gets arbitrarily close to a, f of x gets arbitrarily close to L. Let's look at an example. Consider the function f of x equals x squared minus 1 divided by x minus 1. We want to find the limit as x approaches 1. Notice that at x equals 1, this function is undefined because we would be dividing by 0. But we can simplify by factoring the numerator as x minus 1 times x plus 1. We can cancel the common factor x minus 1 from numerator and denominator. This gives us x plus 1. Therefore, as x approaches 1, our function approaches 1 plus 1 equals 2. Limits are crucial because they form the foundation for both derivatives and integrals. They help us understand function behavior near points where they might be undefined. And they're essential for studying rates of change. This is just the beginning of your calculus journey. Next, we'll explore derivatives and integrals. Keep practicing.